Hey there, and welcome. Today, we're going to get right into the heart of Python by looking at its most fundamental building blocks, data types. Honestly, you can think of them like Lego bricks for your code. If you want to build something that's strong and works the way you expect, you have to use the right bricks for the right job.
So, let's just jump right in with a puzzle that you've probably seen before. Why is it that sometimes when you add 5 and 5 you get 10, but other times you get 55? The answer to this little riddle is the entire reason we're talking today. Python needs to know what kind of information it's working with. Is it a number that you can do math with, or is it a piece of text that you just stick together? Getting that difference is absolutely everything.
And that brings us to the core idea of a data type. It's really just a label, a classification that tells Python what kind of value a variable is allowed to hold. I think the best way to imagine it is a whole collection of special storage containers. I mean, you wouldn't store soup in a filing cabinet, right? It's the same idea. Python needs the right container for the right piece of data, or things just get messy.
Okay, so where do we begin? Let's start at the very beginning with the simplest containers of all. You can think of these as the atoms of our data world. These are the types that hold just one single indivisible piece of information.
In this group, we're going to focus on three really essential ones. We've got our numeric types for, numbers. Then we've got the Boolean type, which is all about logic. And finally, there's this unique object called none, which is basically a fancy way of saying nothing here yet.
First up, the numerics. This one is pretty straightforward, but it's so important. An int, which is short for integer, is just a whole number. Think of it for counting things you can't really split, like the number of people in a room. A float, on the other hand, is for numbers that need a decimal point. For things like the price of a gallon of gas or a precise measurement.
Next, we have the Boolean, or bool. This is the simple yet incredibly powerful engine for all decision-making in your code. It's your yes or no switch, and it only has two possible values, true or false. And here's a little behind-the-scenes secret. Python often treats true as the number 1 and false as the number 0, which can come in handy sometimes.
All right, so we've got our basic atoms down. But what happens when you need to store more than one thing at a time? Well, that's when we start building bigger structures. Let's move on to our first group of complex containers, sequences. You use these whenever you have a bunch of items, and their specific order is super important. Now, in the world of Python sequences, there are three main players you're going to meet all the time. First is the string, which is for holding text. Then you have the list, which is your flexible, do-anything kind of container. And finally, there's the tuple, which is kind of like a list that's been frozen in place. And notice those two key words, mutable, which just means changeable, and immutable, which means, you guessed it, it can't be changed.
This table right here breaks down the key differences perfectly. You can see the syntax is a bit different. Lists use those square brackets, while tuples use parentheses. But the most important column to look at is changeable. A list is what you want when you know you're going to be adding, removing, or swapping items around. A tuple, on the other hand, is for when you want to lock that data down and make sure it stays exactly the same.
And this difference between changeable and unchangeable is so important. A list is like your shopping list. It's designed to be changed. You add stuff, you cross things off. A tuple, though, is more like a permanent record, like a set of GPS coordinates. You really don't want those coordinates to accidentally change halfway through your trip, right?
Okay, so sequences are great when order matters. But what if it doesn't? What if your number one priority is just finding things incredibly fast, or maybe making sure you have absolutely no duplicates? Well, for that, Python gives us two other amazing containers that are unordered.
The first one is the dictionary, or dict for short. And honestly, the name is the perfect analogy. When you use a real dictionary, you don't care if the word apple is the first entry or the 500th. You just flip to apple, the key, to find its definition, the value. Python dictionaries work the exact same way, and they are incredibly fast for looking up information when you have a unique key.
And our last major container is the set. A set is also unordered, but it has a very specific superpower, uniqueness. A set absolutely guarantees that it will only ever hold one of each item. This makes it amazing for a couple of things, checking really quickly if something is part of a collection, and of course, for instantly getting rid of all the duplicates in something like a list.
Phew, okay, that was a lot of information, I know. We've got all these different building blocks. So the big question is, how on earth do you choose the right one for the job? Well, it turns out there's a pretty simple way to think about it. Let's walk through it.
You just have to ask yourself a series of simple questions. First, am I trying to store one single thing? or a whole bunch of things. If it's just one, you need one of those basic atoms, like an int or a bool. If it's a collection, then ask, does the order matter? If the answer is yes, you're looking for a sequence. Then ask, will that sequence need to change? If so, you want a list. If not, a tuple is your safer bet. But if order doesn't matter, then you ask, do I need to look things up using a specific key? That's a dict. Or do I just need a bag of unique items? That's a job for a set.
You know, don't just take my word for it. Python's own official documentation really sums it up perfectly. At the end of the day, you're either dealing with single numbers, ordered sequences, or these unordered mappings. Understanding this and picking the right tool for the job, well, that's not just some academic exercise. It is the absolute first step to writing code that's clean, fast, and that actually makes sense.
So the next time you sit down to write some code, just remember this. Every piece of data, every variable, it's all part of a larger story that you're trying to tell. And the real question you have to ask yourself is, which of these containers, which of these building blocks is going to help me tell that story in the clearest, most effective, and most powerful way possible?